can see even starting up Chrome is a little slower even though compared to Linux. It's really hard to understand.
Yeah, Windows XP. Windows XP.
No, this is Windows 7. Okay, so you have a question about, oh, okay, cannot type my password. So that was a question about one of the questions that we talked about on last Thursday.
Yeah, it was a just practice exam question number 1.
Okay. Looks like I cannot type my own password. There we go. Okay, so this is the 9 o'clock class. And it's under topic 2, right? Are you talking about this one?
Whatever you did on Thursday, whichever one you reviewed on Thursday.
I think on Thursday we reviewed this and also something else. So let's take a look at this one first. And of course it wants to open with Excel. Is that the one that we were?
Oh no, it's the other one.
Yeah. Okay. The other one? Alright, so it must be topic 3. Exam 1. Practice exam 1?
Probably that one, yeah.
Let's take a look.
Oh yeah, so.
Is that the one?
Yeah,
Okay.
so we can't go to number 5 until we complete the while loop, right?
That is correct.
Okay, that's all.
Because it's outside of the loop. So inside, so if when you look at this construct here, let me see if I can bump up the magnification a little bit. Okay, there we go. So when you look at this code here, there are basically 3 levels of nesting. The outermost level is the conditional statement. If x is greater than y is false, then we have nothing to do. We can just get out of the conditional statement. If x is greater than y, then we get into the body of the conditional statement. The conditional statement actually has these lines 2 to 5 to execute when x is greater than y. So the first thing we have to do is to complete the loop first. The loop is starting from line 2 and it ends on line 4. So we cannot proceed onto line 5 to reset x to 0 until the loop is done. Okay. Right.
Once you get to line 5, just when you get to line 5,
then you reset x to 0.
Okay, then you just go straight to 6 after 5. Or
After line 5, we go to post because we do not track line 6.
Oh, okay.
Yep.
For the 4th one on there, you want us to go through the whole there is no inverse function.
Yeah.
For the 4th one.
For the 4th one.
Yeah.
I think you said that we wouldn't have one question 4.
That is correct. I said that I would not give you guys a reverse reduction, which means you don't have to work backwards, but you do have to work forward, which means you have to give me the full reasoning of 1, what is the function? 2, is there an inverse? 3, are you using a substitution or a forget operation? And then you have to give me the template and then do the actual operation. All right. So are there any other questions regarding the practice exam or the exam itself on Thursday?
Would you just say we have the answers for that? Do we have the answers or we can watch
Of which question?
this practice exam?
The ones that are relevant, we talked about it on last Thursday already.
But I'm just asking if we had answers for this, we can watch on YouTube, you said?
Yes.
Yeah.
It is already posted on YouTube, even though there was no audio.
I don't know that you went over number 2 on Thursday.
Number 2, I did not go over this on Thursday because the one that you guys have is simpler than this. The ones that you guys are gonna have is about the same as your homework assignment. So that's why I said when we went over the homework assignment, it's the same as going over one of the questions in the practice exam. All right. Any other questions? Yep.
So in your notes, you did one of those pre and post conditions where it was like y equals 10 and x is less than y, and
it does not matter because as far as line 1 to line 4 are concerned, the value of j did not change. So you can treat it as a constant, at least within the context of that homework assignment.
So if I had switched out in the first inequality or in the first, it said x equals j and then it assigned y is equal to x plus k or something like that. If I had done y equals j plus k, is x and j equal? That would have been wrong.
Let me take a look first. Let me bring up the homework assignment.
Actually, we can talk about this later.
Okay.
When I get to the class.
Well, I had the same question too. It was
Okay, if you have the same question, we can go over that. Because I can consider this, going over one of the practice exam questions, so it's okay. We can definitely take a look. Alright, so this is your homework assignment. It is protected, Okay, fine. I'm gonna close this and use LibreOffice to open it. Alright, so let's open up in downloads, repost. There we go. Bump up the font size. Alright, so in this case, okay, do you guys want me to kind of do this over completely?
Or you could look, because you did it in one of the podcasts.
Yeah.
Right? You did it, and so could you just go back there and show me why that was wrong? Possibly?
Okay, so, well, I think it's easier for me to go over,
Yeah,
just
that's
do
fine.
this all over. Okay, so in this case, pre-1 is true, that's given to you. And since it wants to fix itself, I need to turn off all the autocorrect options. Okay, let's see if that helps. Okay, so for line 1, for every single line, there are several things that I look for. The first one is, what is the function? In this case, on line 1, f of x is j. Okay, some people wrote down x gets j. That is not the case. It is really just the right hand side. So j is the definition of the function of x. And then the next thing I look for is does this have an inverse function? No inverse. Okay, that's all I need to know. Okay, just tell me there's no inverse function for this particular function. And then you have to tell me what operation we are going to use. So in this case, because there are no inverse functions, we have to use the forget operation. And then we have to look at the post condition of line 1, which is derived as a result of forgetting something in the precondition of line 1. Anything that mentions x, we have to forget. But then we also have to add, from now on, x equals j. And I specifically said do not use the assignment operation here. In other words, this needs to be an equal sign. Because as a condition, we cannot say x gets j. X gets j is neither true nor false. It is an operation. X equals j is a comparison. It is either true, yes, x equals j, or false, x does not equal j. So that's also one of the important things that you have to remember is we do not use assignment operations inside the conditions. Are there any questions up to this point? The template itself is worth points. It is important. In other words, some people got this part right and somehow did not carry out the forget operation correctly. Those people still get partial credit because the template is correct. Okay, so the next line of the expansion is really just to substitute whatever pre-1 is into pre-1, and then we just do the rest. Quite a few people, more than just one, for whatever reason, kept saying pre-1 is true throughout this code here, which is not what I want. I mean, this is a part of the answer, because pre-1 is true should be expanded inside this forget operation. In other words, pre-1 is true is reflected here. Are there any questions about that part? No questions? All right. So if you look at this, there's no mentioning of x in true, so we can keep the entire thing. So true, we can just keep the entire thing, and x equals j. There's no need to do the simplification. If you just leave it the way it is right now here, it is considered a 100% correct answer. Yep.
And just a quick question again. You already said this, but what's the difference between x equals j and the assignment of j to x?
One is an operation to make x equal to j.
Mhm.
The other one is stating, is asking, is it true or is it false that x equals j?
Okay, so okay.
In this case, we need the condition, not the assignment operation.
Okay.
We are stating the fact that x does equal to j. We are not stating the operation to update x so it becomes j. All right, so this is the first part. The second one is for line 2. For line 2, we want to do exactly the same thing. In this case, it is f of y equals to x plus k. Quite a few people, think that there's an inverse function, but there's none because x does not mention y, k does not mention y. In other words, the entire right-hand side or the definition of the function does not mention the independent variable in the function itself. So that's why it's not reversible. So in this case, you still have to say there's no inverse function. Use the forget operation. Now, when we use the forget operation, yes.
Unless x of k has a value, right?
Say again.
Unless x of k has a value, then you gotta use an inverse function.
No, because in this case, nothing here, nothing about the definition of the function refers to y, so it's not reversible. It cannot be reversible.
Okay.
Because it does not depend on y at all. The value of the function does not depend on the independent variable y. So that's why it cannot possibly be reversed. Yep.
So if it's f of y equals y plus k, it will have
If it were y plus k, then it is reversible by using y minus k. But since it's not, since it's x plus k, it cannot. It's not
these
reversible.
are constant, right? These are constant? Both of them?
As far as this line 2 is concerned, you can consider x and k as constants. Yep. Mhm.
Instead of k, if it was just the one, it
It will still be irreversible because it does not refer to y. If the right-hand side does not refer to the left-hand side, there's no inverse for sure. All right, so in this case, we also know that y equals x plus k afterwards. And once again, we have to use the equality symbol here and not the assignment operator. And in the next line, we just expand what is pre-2. You don't have to, do anything. You can just copy and paste the entire pre-2 over here. And I think, some people, for whatever reason, change the condition to something less than something else, which was never mentioned in the precondition. And then what you need to do is to look at this expression here and say, do we have anything that mentions y here? The answer is no, there's nothing that mentions y. So the forget operation has nothing to forget, which means you have to keep the entire thing. So you have true and x equals j. Keep the entire thing here. And then the other part is outside of the forget operation. So you have to keep this part, regardless. And I think some people also forget about this part here. It's outside of the forget operation. So that's the answer of line 2. Yep.
I have a question. Since x equals j, if you put y equals j plus k equals x plus k, I mean, is there any penalty for switching j and x out?
Nope, there's no penalty.
But won't it affect the final answer, since the final answer requires a substitution of that x equals j?
That is correct. It does affect that. But I'm not going to take any points off.
Okay.
Yep.
That's confusing.
Your final answer will still be correct because j never changed its value during, in these 4 lines of execution.
Mhm.
So if you just, say that y, I think it's y divided by 2 equals to j plus k, it will still be 100% correct. There's nothing wrong with that answer. because it is still true, because at that point x minus 1 equals j. So if you switch it, it will still be okay.
What if it? Okay.
Okay. All right, so let's work on the third line. Okay, the third line is, we have to use the same steps here. We define the function first. And then after we define the function, we have to say, is there an inverse? In this case, there is. So we have to say f prime of x, which in this class we use that to denote the inverse function, is x minus 1. And quite a few people also forget to state, okay, here's the inverse function. Instead, just use the inverse function inside the substitution operation. So in the substitution operation, we say use sub operation because there's an inverse function. To get to the post condition of line 3, we apply the substitution operation. Yes?
Do you have to type in an inverse f of x equals x minus 1, or can you just leave the inverse out, just type in there?
I would prefer that you spell out the entire thing like this,
Okay.
because that's what I did in class.
No, I mean put the inverse before you type out the inverse function. Like what you did last time, you typed in inverse f of x equals x minus 1. Or you can just leave the inverse word out and just type in the inverse.
You still have to refer to the f prime of x inside the substitution operation, because the template of the substitution operation looks like this.
Oh, what I meant is, if you don't type an inverse on that second line,
Right.
we should do that. Consider that correct.
You have to make it clear that you know what the inverse function is. Yep.
I think he means how on line 2 you say no inverse, use forget.
Uh-huh.
And then an example you used on line 3, this function has an inverse, just
Right.
spelling out the sentence. I think
That's
that's what
what
he
I
meant.
Um,
You have to spell out the sentence.
You have to tell me what the inverse is in that
Okay,
case.
just
Yep.
that.
Yep. So I would spell it out like this. And that's why we have step 1, step 2, step 3A, step 3B, step 3A1, step 3B1. Remember all that stuff?
Mhm.
Well, I presented that stuff for a reason, right? All right, so now we do the substitution operation. With a word processor, it's a lot easier because we can just copy and paste. So we look for occurrences of x here and replace every single one with x minus 1. So in this case, we have 2 occurrences of x. So the end result is true is still true. In this case, x minus 1 equals j, and in this case, y equals x minus 1 plus k, just like that. Are there any questions? Yep.
So that's where my question about the j substitution comes in, because y equals j plus k is different than y equals x minus 1 plus k, isn't it?
No, it's the same, because if you look at this, because we know that x minus 1 equals j, so if you put a j here, it will still be okay,
Okay.
because they still are the same.
That makes that
Yep.
makes sense.
Yep, go ahead.
So is true still optional because on the example you showed on
True
Thursday?
is still optional, because,
Okay.
yeah, if you put true throughout the entire thing consistently, you're fine. The simplification of true and, get rid of the true and whatever, is optional.
But if you miss one, then
I don't think I checked really that diligently to make sure everything is consistent. So I only check for really obvious mistakes. Yep.
If you make a simple mistake like forget to put open parenthesis, you take points off for that.
No.
too? No. I think you're missing one open parenthesis in
I did.
3, 5. Between the sub and the first one.
Below or above this line?
Below that line.
Here?
Yeah. To the left. You went right to the left. The first open parenthesis on the left side.
You mean this one?
Yeah.
It's closed by this parent. I don't think I missed anything. Open, close, open, close, open, close, close. I think they're all matched.
So I'm seeing missing one because that one flows dead. That one flows dead. That one flows dead.
Oh.
No, sorry.
Oh, okay. Never mind.
Okay. All right. Let's move on to the last one. Now, by the way, this is a complete review of what we did on last Thursday. So I'm hoping that you guys realize, this is the stuff that we have gone through already. But having a second exposure does not hurt. Okay. So in this case, 2y has an inverse function of y divided by 2. 0.5y is considered as a correct answer as well. So you can put it any way you want as long as it means the same thing. We use the substitution operation, and as a result, post 4 is based on the substitution operation on pre 4. We look for occurrences of y, which is the variable on the left hand side. We place every single one of those with f prime, the inverse function applied on y. And then the result becomes like this. I first expand what is pre 4. Pre 4 is this big mess here. And just copy and paste it. And then we look for occurrences of y and divide every single one with y divided by 2. And then the result of the operation is going to be, there's only one place we need to do any substitution, which is right here. So we replace this one with y divided by 2, and that becomes our solution of line 4. And since line 4 is the last line of the 4, we are done here. That concludes the entire answer for the homework assignment. So in the test, when you see something like this, you will have to go through the same steps. Okay, you identify what the function is. Is there an inverse? If so, what is it? What operation are you using? Give me the template of the operation itself, and then carry out the operation the way it's supposed to. Okay. Any questions about this particular assignment?
So you don't put post after the last final line.
Say again?
You don't put post after the final line.
No, this is not a trace. There's no post. Or if for those of you who are mathematically inclined, you can always say QED to say that this is end of proof. Or put a little square block here. So are there any other questions about this particular homework assignment? Yep.
So it's just implied that pre-4 is supposed to be, you don't have to write it out.
I did not, mark any points off, if people miss that. But it is important to kind of know that, it is implicit that the precondition of a previous line is the post, excuse me, the post condition of a previous line becomes the precondition of the line following. All right, any other questions? Yep.
How many questions are on our test?
That'll be about 5 questions or so, and this is one of those. Why? Not enough questions to no. Too many. Well, I don't know, because if there are too few questions, each one carries a lot more weight. So that may not be beneficial either. Yeah. You want to make sure that you have enough questions and yet have enough time to finish all the questions.
On some of your practice questions, it says, if this is not possible or an infinite loop, explain why. I mean, can we just say x is less than y, therefore there's nothing to complete in this if-then statement, or like you give a little if-then statement and say if x is equal to y,
An if-then statement can never be a part of an infinite loop.
I know, but you ask for explanations as to why something won't work, or just simply say that this can't be executed because x is equal to y. Is that simple enough, or?
You have to say that the variables are not getting changed after one entire iteration, and that's why if nothing is getting changed in an iteration and the condition is true to begin with, then it can never become false because nothing is getting changed. So that would be the proper explanation of why a loop is infinite.
You say that again.
Okay, let me just give you an example instead. The question is, how do we explain a loop is infinite? Here's the answer. Okay, so I'll just go ahead and write a loop that is infinite to begin with. And this time I do want the replacement table to be back on again, so I'm going to go to autocorrect, go to the options, turn on the replacement table. Okay, Okay, so in this case, I have x get 0, while x is less than 3, do the following. And in here, I'll just go ahead and get y incremented instead of x. Okay? This is a classic case of an infinite loop. Okay? So when you just look at this loop here, some people can kind of recognize and say, hey, since x itself is not getting modified, if x is less than 3 to begin with, that condition will stay true no matter how many times we go through this iteration. So the explanation is, since x is not getting modified by the loop, if x is already less than 3 to begin with, it will remain less than 3 no matter how many times we go through the iterations. So that would be a proper explanation. Any other questions related to the exam?
Now, if you give us something like that, can we just put in the bottom row like infinite loop?
You have to explain to me why it is an infinite loop. It is your explanation that is worth points.
Okay.
Yep.
Can we do the one that has if statement nested inside of a while statement nested inside of an if statement?
So you want an if and then a while and then the if inside?
Yeah. So it's an if within a while within an if.
Okay. Yep, we can do that. No, you can. I can always make something up. I mean, that's.
You actually have it on one of your exam questions. It's I can give it to you.
Okay. Let's
I have it
see.
written there. You guys want to pass?
Do you
it
know
on?
where I?
Yeah, it's underneath the exam practice questions. I think it's the very last one,
The very last.
but it's written down right there.
Okay. Oh, it's the same one that you mentioned.
Oh, okay.
Yeah. So we actually looked at that just a little bit ago. Alright, ignore that for now. Let's see. I think it was this one. It's right here, right? No. Okay, yours actually has one more level of conditional statement. Fine. We'll go ahead and write it here. Okay, so this is the. I have to change the autocorrect again because the replacement table identifies I, lowercase I, as a typo, and it always wants to remap it to uppercase I. We have to change that. Get rid of this one. Okay, so now I can type lowercase I without any problem. If I is greater than 3, then while I is not 5, I is less than 6. Do if I does not equal to 5, and I gets minus 1, and if I gets minus 1, well, alright, so this is the entire program, and we have some indentations to fix here. Alright, so that looks right to me.
We have to get that x is equal to 0 out at the top.
Oh, okay. Well,
Then
that.
you've only got 8 lines.
Alright, so does it has to start, it has to indicate a start condition, like what is the initial value of I? Does it mention anything like that?
With this one, you want us to continue to trace. So right now, it says that if you're at line 6, I is equal to 4. That's all.
I
it's
equals
providing.
4 on line 6.
Line 7, I guess.
Nope. Yeah. Line 6. Okay, got it. I think we might have seen this one before. This is the one where it is not possible, right? Unless we have a go-to statement. Okay, well, let's go ahead and take a look again. So we have only I here. And you mentioned on line 6, I has a value of 4. Okay. All right, so let's go ahead and make that assumption. All right, so now that we know that we are on line 6, I has a value of 4, so that means line 6 is already done at this point. Where do we go next?
Line 2.
We have to go to line 2, and line 2 is reevaluating whether I is less than 6. I is less than 6 is true because I has a value of 4 at this point. And then we get into the loop. When we get into the loop, where do we go next? We are on line 2 right now, so we go to line 3. Line 3 is the beginning of a conditional statement. We have to evaluate the condition of the conditional statement. I does not equal to 5 is true. So that means we have to go to line 4. Line 4 is adding 1 to I first. So I goes from 4 to 5. And then we get out of the conditional statement because there's no else. Well, you know, whether there's an else or not doesn't even matter because we have executed the then branch already. So where do we go now?
6.
Line 6.
I was gonna say that's you actually answered my question, but just so I know that I have it correct in my head.
Okay.
Is that when we have a loop nested within a conditional statement,
Yeah.
we're going to continue to loop that statement until we're done or get a false with the while statement or the loop?
Because when you look at the structure of this thing, we have a conditional statement, right? So when you look at the overall statement, it is still a conditional statement. And the conditional statement does not have an else, which means, you know, if the condition is false, we basically bypass the entire thing to skip all the way to the end of the conditional statement.
Right.
The loop is on this side. So now we have a loop in here. Oops. So that's why you have to finish the loop first, and then there's also line 6. Well, that's the entire loop. So this loop is the entire thing here. And then inside the loop here, we have a conditional statement followed by a particular statement. So inside here, if you look at this part here, you can expand it to a conditional statement with only one side because it also does not have an else portion.
Right.
So this part, you know, kind of looks like this also. But after the conditional statement, we have one additional assignment statement. So when you look at this little portion here, it expands to a conditional statement followed by a single block representing an assignment statement.
So the one that you blew up on the right, that's the if statement with the end if. That's why it's either true or false, and if it's true, then we move it.
Yeah,
or we do it.
Yeah, this is representing from line 3 to line 5 here. This is line 6.
Right. With the increment of plus
The
1.
increment of I.
Right. So we are gonna keep on looping until we get a false on the while, and then we can.
The false on the while will get us out of the then branch of the conditional statement. So when we exit the loop, we are also going to exit the then branch of the conditional statement. But exiting the then branch of the conditional statement will also make you exit
a
the
false on the end conditional. So that means you're just gonna pull right out. You're not gonna come back up to line 1 because
there's no
something else
path
that's
to
got a
go
false.
back up to line 1.
Right.
Because it's a conditional statement, it is not a loop. And I think we might have looked at this one already, and I kind of stated, you know, it is not possible to have a value of 4 on line 6. Do you guys kind of vaguely remember that? Yeah? No? Does anyone know why, you know, or if I did not mention it, can you see why it is not possible to have a value of 4 on line 6, at least the way this particular loop is structured? Yep.
Because
you can't get into the loop unless I is less than 3.
Correct.
So
Yep. Well, you cannot get into the loop unless, okay, let's take a look. This is line 6 and I has a value of 4. This is line 6 and I has a value of 4 after line 6. So if I has a value of 4 after line 6, what is the value of I before line 6? 3. So that means 3 is going to be here or possibly up to here. If I has a value here, what is the value of I before this line? 2, and it will meet this requirement, right? And I is less than I has a value of 2 will meet this requirement, but it won't meet this requirement. We cannot get into the conditional statement without I being at least 4 in this case. So that means by the time we get here, I cannot possibly have a value of 4. But that's my flaw. That's my fault. With this particular case. But given that I has a value of 4 on line 6, that's how we continue the trace. Yep.
If you made a mistake like that on the test and they answered it in either way, would you give them full credit?
Well, you can either explain why it is not possible to have a value of 4 on line 6, or you just trace it the way it is given. All right. So are there any additional questions about the practice exam? Questions?
Row sheet.
Go ahead.
Row sheet.
Row sheet. So once again, the exam is open book and open notes. Okay, I'm hoping that you guys will use this opportunity to prepare, something to help you with the exam. How many people are planning to bring in, something that you are going to prepare into the exam? Okay, very good. I think just the preparation of that material is going to be helpful already. Here's the row sheet. Just start a new column on the right-hand side. Thank you. And I'm going to give you. Just give me this back.
And when are your office hours? Because your syllabus gives lessons.
It's always from 8 to 9.
8 to 9 every day?
Yep, 8 to 9 every day except for Fridays.
Okay.
8 to 9 every day. Oh, I got classes all those days.
Where you have the exam 1 archive on topic 3,
So I'm screwed either way. I got classes all those days.
it comes up as some tar.gz file that doesn't open with LibreOffice.
Okay, that's a Unix type of format. You can use 7-zip to open it. So you can go to 7-zip, download 7-zip to open it. So this is a particular program that you can use to open up a tar.gz file.
And it opens it up, is it LibreOffice or that?
Well, it opens up the tar file, which is kind of like a zip file, and then inside you will find either PDFs or open office files. All right. So are we ready to move on to the next topic? Kind of. All right. We were on pre and post conditions, and now we are on to okay, I think there's a problem here. The topics are out of order. Because we are supposed to be talking about top-down design instead of arrays at this point. So I'm going to move the topic back here using top-down design. All right. So we are going to start with the whole concept of top-down design today. I'm pretty sure in this class we have not gotten started with this topic yet. Is that right? No? Okay, very good. All right, so what we'll do is we'll talk about top-down design in real life first, and then we'll go ahead and talk about why do we need this kind of practice in programming. So the first thing I want to do is to kind of talk about your English classes, English writing classes. How many people have taken English writing 300 or English writing 1, okay? So do you just sit down, on your final paper, on the final term paper, and just start writing from the beginning to the end in one single shot?
No.
So what do you do? What kind of techniques do they teach you in a writing class?
Make an outline.
Make an outline, okay. So why do you make an outline? What is an outline anyway in a writing class? Structure, okay.
Like flow chart, just kind of like it's very, just gives you the outline.
But what is in the outline?
Order.
Reasoning.
Reasoning. But do you give it a lot of details? Like throw everything, into the outline?
Keywords.
Keywords.
Subjects.
Topics.
Subjects. How about key components of your paper? The first part needs to talk about this. Just use one sentence or a phrase to describe what you need to put there. And then we have to move on to this topic, and then the conclusion. Right? That's what an outline is. But why is outlining useful when you're writing a fairly long paper?
Keeps you on track.
Keeps you on track.
Organized.
Okay. So if you don't do an outline, what would happen?
Paper might be unfocused and kind of all over the place.
Okay.
Disorganized.
Disorganized. Okay, very good. But why do you think, if we don't use an outline to kind of keep track of, the overall structure of the English paper, that we'll start to get off track? And it doesn't happen to just you, right? I mean, it happens to anyone who tries to do, who tries to write a long paper without an outline. Why do you think that's the case?
Start yakking.
It has to do with our short-term memory. Okay? How many things can you track in your short-term memory? That really is the question. What do you think? How many things can you track in your short-term memory?
Not much.
32 bits.
32 bits, that's a lot of stuff. I certainly cannot track that many things. A 32-bit number can be up to 2 billion or so, and I certainly cannot remember a number, up to 2 billion something and spell out every single digit. We can track about 6 to 7 objects. Okay, our short-term memory is really limited in terms of how many concepts we can track at any particular time. So if you look up, on this, very topic, okay, if you just go to Google and search for short-term memory, so the key part here is most people have a short-term memory capacity of 2 plus or minus 2 elements. To me, it's probably around 4. I really have, my memory is bad, okay? Long-term or short-term, I have really poor memory, and that's why, unless I understand something completely, it is almost impossible for me to remember something.
That's why
Okay.
you lost your bag.
Sorry?
That's why you lost your bag.
That's how I lost my bag, exactly. I lost track of where I put it. In contrast, long-term memory can hold on close to an infinite amount of information. The key is whether you can retrieve that information or not. It is here somewhere, but what is the key to retrieve that information? That really is the question about, in terms of long-term memory. But in terms of short-term memory, which is what we need when we write an English paper or write a program or find a location on a map, that's what you need in terms of, that's the kind of short-term memory that you need when you're dealing with those problems. Are we doing okay so far in terms of these concepts? And that's why puzzles are challenging. Okay, when you try to put together a puzzle, like a 2D puzzle, those are challenging because you have so many pieces of things to keep track of and to try to match up, okay, I think this piece goes here because this part of the picture seems to match this part of the picture. But what if you have a puzzle where there are many pieces of about the same kind of color and all of the pieces are about the same shape? Well, then it becomes very challenging because you cannot keep track of all the pieces available to you and all the slots that are still open on your picture. Okay? All right, so given this is the case, let's go take a look at something that seemingly has nothing to do with programming. And I've been typing already, the Google is just, not Google, I don't think it's a Google Chrome issue, but it's Okay, let's take a look at Google Maps here. Okay, we'll go ahead and zoom out a little bit. Let's look at the overall map of the United States with some states from Canada. We'll try to zoom in a little bit. That's good. That's good. All right. Do we have 7 items here?
No.
No, we have a bit more than 7 items. So that means this is already difficult for for anyone who is not familiar with the United States. Finding a particular state given this picture is already a little bit hard. Okay, it's not impossible, but it is a little bit harder because if you're not familiar with the country and know, okay, I think that state is around here. Okay, you can then search for a particular state really quickly once you know it is on at least the the East Coast, the West Coast, the interior, to the north, to the south, or whatever. Okay, for instance, if I switch to a different country, that would really kind of help to make that point. So if I try to name a particular state here, I think for most people it will be a lot harder to find the state because you're not familiar with the geography of China. If I say Tibet, it's probably easy, because Tibet has a lot of publicity. But for some of the other states, it just doesn't have the publicity. So it becomes harder to find a particular state. But getting back to something that we already know, if I ask you, where is ARC on this map, do you think it is somewhere on this map here?
What?
I mean,
Well-
technically it is, but it would be very hard to pinpoint because it's.
It'll be very hard.
It's in the state of California, but then within California, it's in a certain city. Within a
Right.
certain city, it's in a certain county, and it just keeps digging. So.
Yep, exactly. But that's basically the whole idea of top-down design. What if I tell you this projector has infinite resolution? In other words, we can display any amount of detail infinitely, with this projector. Now, of course, if the projector has an infinite resolution, you will also need a microscope with infinite magnification to read the map. So what if I give you both of those? The projector itself has an infinite resolution, and I give you a microscope that also has infinite magnification. Would it still be easy to find ARC on this map? No, it would not be easy. Why wouldn't it be easy?
You have to search around for it.
You still have to search around. Okay. So in this case, we have top-down design here. This is the top level of looking at something, and then we can kind of circle. We can zero into California or Central California. Now we can see Sacramento. We know ARC is in Sacramento, so we don't really care about, let's say, Yuba City or Roseville or Stockton at this point because we know we are just interested in this portion here. So if we zoom in a little bit more, and then we say, okay, we know that ARC is around here in the northern part of Sacramento. All right. So now we know that ARC is on College Oak Drive, which is not shown on the map yet. But we know it is next to Auburn and Myrtle. So now we can focus on this part here, and here we have ARC. Now once we have ARC, we can try to find this classroom.
Good luck.
Yep, it's amazing how detailed Google Map is. So we are in liberal arts, and then we can try to find this classroom by its relative location relative to the boat building here, okay? So if you walk outside, make a left turn, you will see the boat building, which means we are about here, because you go outside, make a left turn, you will see the boat building. So that means we are located right about here. This is our current location, okay? But every time you zoom in, you don't see any more than, let's say, 50 or 60 names at the most, okay? Because that really is a lot to push already, to search through about 50 names for the one thing that you're looking for. There's another analogy of top-down design or why structure is useful. Remember, how much storage you can buy these days? How much is a 4 terabyte hard drive?
Depends on the brand.
Hmm?
Depends on the brand.
Good brand.
Seagate, $300 bucks.
$200?
$200-300.
$200 or $300?
Yeah.
So if I give you a free 4 TB hard drive, but the limitation is you can only have one folder, the root directory, would that drive still be very useful?
It has a search option.
A search option can be helpful only if you have searchable files or files that have tags that you can search on, right? So for documents, yes, you can probably search the documents, but when you try to put so many files into one single folder, even searching by a tool can take a long time. If you filled up a 4 TB hard drive and your only tool to look for something is to search for search for the content, you will either end up with a lot of hits, or it will take a long time to search for the file that you want. So it's the same thing, because without organization, having a 4 TB hard drive is not going to be very helpful. Okay. Is that making any sense? Unless your 4 TB hard drive's only purpose is to back up another 2 TB hard drive, then it's okay because you end up with one single file, which is the backup of the other drive. But if you want to use it to store files, individual files, images, documents, and so on and so forth, having that capacity but without subfolders is not going to be very helpful. Now, in programming, we have one specific requirement because it has to do with how many lines can you fit on one screen. That really is a big problem in terms of programming. All right, so this is the rationale. I'm just trying to look for the one that I really want to talk about. Okay, algorithm specific consideration, that's the one. Okay, so when you're writing programs, writing algorithms, you also have the limitation of how many lines can you display on a single screen. What do you guys think? How many lines can you fit on a screen? Not really counting what you're seeing right here, because I have to use a much lower resolution than I normally would, because it's projected to the entire class. So let's just say that you are using your typical 1080p monitor, which has a vertical resolution of about 1,000 pixels. So how many lines do you think you can comfortably fit without having to kind of squint and look at the fonts funny? 100? 40 to 50, 100. I can live with 100. Sometimes I do use very small fonts and extend my terminals to about 100 lines. But that's about it. I cannot display any more than 100 lines. So what if you have an algorithm that requires, let's say, 2 screenfolds? In other words, what if you have a 200-line algorithm that would not fit on one single screen? What happened to the beginning and the end of the constructs? The while matching the end while, or the if matching the end if? What happened to all those matching when you cannot fit everything on one single screen?
It breaks up so that it's harder to see what where things are ending and beginning, all that.
Exactly. So when your algorithm cannot fit on one single page, then you end up with a problem of not being able to see the beginning of a construct, even though you can see the end, because it just won't fit onto one single page. In the good old days, we had what we call fan folded paper for computer printouts. Many of you are way too young to remember or to have seen those what we call fan folded paper. So it's a good time to kind of look up a picture of fan folded paper of a long listing, a program that is really long.
Is it that
So
green and white line paper?
Some of those have those, but you can also get it in completely blank and white type.
Talk about that analog that sounds like a typewriter.
Talking about the one long reading of paper that's folded like this and it has the dots on the side to hold it around the bed on the computer.
Yep.
Yeah, bingo.
That's what we're talking about.
Yeah.
So it looks like a
Antique.
when they come in stacks, it kind of look like this. Okay, it's called fan folded because it's folded like this, kind of in a zigzag way. They have special holes on each side because the printers, would kind of have rollers, to kind of roll onto those pins or pins to get through the holes. So that's how it is fed through a printer, and those are typically fed through either dot matrix printers or what we call line printers. Does anyone know what is a line printer?
Printing checks.
Hmm?
For printing checks.
They print checks. Okay, line printers are very interesting Because what happens is, instead of having a print head that moves across in order to print either the dots or the typewriter head to print one letter at a time or one row of dots at a time, a line printer has as many heads as there are number of characters per line. So if you're dealing with a 132 column printer, you have 132 wheels that are all working independently on the printer. So in order to prepare to print on one line, you have all 132 wheels rotating to the right position all at the same time. So they will go like this all at the same time, and when they're all done, the entire row of wheels will impact the paper all at once. It prints one entire line at once. Okay, and you can kind of imagine the kind of mechanical stuff that it has to go through in order to do any type of printing. It's exceedingly fast, okay, because you're printing one entire row, 132 characters all at the same time. But it is also it has a lot of vibration because there's a lot of mechanical stuff going on and impacting on the paper. When I was in college, they used to have one in the printer in our lab. It's when you lean against it, it's a really good back massaging machine. And I'm not kidding, it really is, because it's really quite at the right frequency, and it's just going like that, and it has the right kind of motion too. But maintaining those things, it's really just expensive. Now, getting back to this part here, I want to show you a long listing program. This one is not bad, but I want to show you something that's really long. And this is probably a line printer back in those days. Found a picture once that was really good.
Is it an algorithm?
Now, let's see if I can. Yep. Okay, I cannot find it. I'm not going to waste too much time here. But I have seen programs that are so long, it will take like a few pages to show one entire algorithm. So when you have an algorithm that complicated with a few pages, and you have the beginning of one construct on page 1, and then the end of that construct is on page 4 of the same listing, how do you match up the beginning and the end of a construct? Even with indentation, it will still be difficult. I have seen people laying out that kind of a program on the floor and use a really long ruler to help line up the indentation and then draw lines to say this is the beginning, this is the end of one particular construct. Okay, and you can kind of imagine how difficult it would be to keep track of everything going on in an algorithm like that.
Why would they print it out?
Because you cannot see it on the screen. Because back in those days we had dumb terminals. Dumb terminals can only display 80 columns and 25 lines. Your printer can print about 66 lines per page. So it is still it's already a big advantage over using a dumb terminal. Okay? So that's why it is not easy to keep track of algorithms unless you kind of break it up into smaller portions. So that's why even with correct indentation to help us identify the beginning and the ending of blocks, if a construct spans over several physical pages, it will still be difficult to match the beginning with the end of the same construct. So that's why even with good programmers, I would say 40 lines or so per algorithm. It's about the limit. Okay, some people can do a little bit better. Some people can handle maybe up to 60 or 70 lines, but that's about it. I mean, you don't really want your algorithms to exceed 60 or 70 lines, unless it is a very special kind of program. where you cannot really break up the code. Okay, for this class or for any class that is in kind of in the beginning stage, I would say about 20 lines is how far you should push it. If a particular algorithm is longer than say 30 lines or so, you should consider breaking it up into smaller algorithms. Okay. So here is the biggest question: how do we break a bigger algorithm into smaller parts? That is the question, and that's the whole purpose of this particular topic: is how do we break it up? In other words, how do we actually apply top-down design? Okay. So instead of just reading my notes, because most of you all of you are supposed to have read this before coming to class. So instead of reading my notes here in class, what I will do instead is I'll give you an example of how to write an algorithm. And in this class, I'm just going to use Notepad and make sure that the font is big enough.
To writing algorithms, you have to use a specific program, or it doesn't matter?
All programs are, well, most, I should say all, but most programs are really just text files. So Notepad, should be okay, with most programs. Notepad is not the best editor for programs, but for this class, it's okay. The reason why Notepad is not good for, let's say, Perl programming or any particular programming language is it does not have syntax highlighting, whereas other editors do have the syntax highlighting. But in this class, we're not too concerned about that. So let's see, we have 5 minutes left. I would like to at least go over what we are about to do so that we can continue this next Tuesday. On Thursday, we have the exam, so next Tuesday is the time that we'll continue with this discussion. So what I want to do is to write a program that will print out all the factors of a particular number. Okay? How many people still remember factoring a number? Okay, most people. Well, many people did not raise your hand, but I think most of you still remember how to do it. So let's say we're dealing with 36. Okay, I'm going to use the Notepad here so I don't write anything on the whiteboard. Okay, how do I factor 36? What are the individual factors of 36?
3, 3, 4.
All the prime factors, how about just the prime factors? It has a 2, right? Now, instead of just trying to spell out every single thing without going through steps, let me just do it in a very simple way. Okay, I would say 36 is 2 times 18. It's fairly easy to identify that 36 at least has a factor of 2, right? Because if you look at the least significant digit, which is 6, it is divisible by 2 itself. Okay. Now we only have to look at 18 because the 2 is taken care of. Now we look at 18 and say, well, what about 18? What kind of prime factors does it have?
2 and 9.
2 again. Okay, 2 times 9. And then we look at 9 and say, well, what is a prime factor of 9? Does it have 1?
3, 3.
3 times 3. And then we have 3 left, which is 3 again times 1. Now this one may look redundant, but it is necessary. Because what we have here is when we say 9 equals 3 times 3, the first 3 is a prime factor, the second 3 is what is remaining to be factored. So when we look at 3 again, this 3 is a prime factor because 3 is a prime number itself, so it is its own prime factor, and then times 1. Yep.
Just a side question, how come they haven't used like a computer program to figure out like a prime number theorem or anything?
How come?
They haven't used a computer program to figure out how many primes there are before a given number.
Yeah, I would assume that there are algorithms to do that.
Oh, okay.
Yeah.
It hasn't been solved yet, that's why I was asking.
There are how many, okay, your question is how many prime numbers there are.
Before, so if I give you the number like 1,000,000, how many prime numbers are there before that? They haven't figured out an equation for what that is.
There's no equation to do that. There's no
Correct.
closed form to do that.
Correct.
As far as I know, there are no closed form.
I was just wondering why they haven't used computer programs to see if they can suss it out or something.
Yeah, I don't think there are any algorithms to give you an exact number. I think they can tell you they can give you the maximum number of prime numbers up to a certain point, but they cannot give you the exact number up to that certain point. Okay, so let's take a look at a different one. Let's take a look at 17. Okay, if I want to factor 17, how many prime factors does it have?
One.
It has 1. Any prime number is its own factor. Okay, so 17 is 17 times 1, and since you know the next number is 1, we're done here. Okay, let's take a look at 15. 15 is 3 times 5. 5 is 5 times 1, and then we are done. Okay, so this is how we find all the prime factors of a particular number. Okay, great. Let's go ahead and try to write an algorithm to do this. I'm not going to do it today because you know I cannot do it in about 2 minutes. But I do want to point out when I do show you how to derive an algorithm, you might want to kind of participate in that process, because this class is called Algorithm Design and Problem Solving. So part of what I need to teach is how do you design an algorithm, okay? Which is one of the hardest things to teach. I would say the pre and post condition is easy to teach, because once you understand the concept, those operations are fairly mechanical. The only part that is not mechanical is finding the inverse function of a particular function. But even that one is, you know, we only have add 1 and multiplication, you know, with this class. But designing an algorithm is not quite the same. Okay, it's almost like writing an English paper. How do you write an English paper? Except in this case, logic is also very important. So it is a little bit hard to describe. And sometimes, you know, if people ask me, you know, Tech, how did you come up with this algorithm? I cannot answer that question. It just kind of formulates, you know, quickly in my mind, and I have the solution. So by the time I get to describe an algorithm to do just that, it is probably a good time for you guys to kind of participate in the process and be able to understand, you know, what kind of rationale or what steps you can take to approach a problem step by step. Okay? I'm not going to do it today. We don't have enough time to do it, so I'm going to end the class a little bit early today so that you have enough time to prepare for your exam. There's no homework assignment, you know, so that we can focus on just the exam. I'll see you guys on Thursday, and please be here, you know, as early as possible so you can get your favorite spots.
And where's your office located?
My office is number 7 in Liberal Arts 133.
Number 7 in Liberal Arts, number 33.
133.